elements in the periodic table. And to start off, we're going to define some terms. We're going to define what an atom is, an element, and a molecule, and the differences between them. To start off, an atom is the basic structure of matter, which means that whatever it is, the material that you're getting, an atom is the simplest, most basic, the smaller you can get and still be that material. For example, here we have copper and iron. And then, for example, an element is the substance that consists of atoms which all have the same number of protons. An element, it's like it's a molecule, but it only has one type of atom. For example, here we have a molecule of hydrogen gas, which is composed of 2 hydrogen atoms. And if you notice, it's only hydrogen. And on the other molecule, it's an oxygen molecule, and it's only oxygen. Like an element, it's a molecule with just one type of atom. Next, we have a molecule, which is a group of bonded atoms. Here we have, for example, carbon dioxide and the H2O, which is a molecule for water. If you notice, the difference between an element and a molecule, it's that an element only has one type of atom and the molecule has multiple types of atoms. Next, we have the atom structure. Here, this is what an atom looks like, but it's not drawn to scale. I mean, the electrons, if this was drawn to scale, the electrons will be like way farther than these are drawn. But just to know the basic structure of an atom, we draw them like this. So the first part of an atom, it's the nucleus. The nucleus is composed of protons, which here are purple, and neutrons, which here are red. The protons have a positive charge, and the neutrons have no charge. Next, we have the orbitals of the electron, which are in green right now. And this is the path that the electrons take. Well, they're in the atom because they're always moving. And then the electrons, here it's that green ball, and they have a negative charge. The number of electrons and protons should be the same because the atoms want to be in a neutral position. Now we're going to move to the periodic table of elements. And this is a basic structure of what the table looks like. You can see there's not much detail in it, but it's just to see more or less what it looks like and the patterns that we see according to the properties that it shows us. For example, here the periodic table of elements shows us how the relation between how the atoms are set up in the table and their atomic number. According to the table, they're placed in increasing atomic number, and then, for example, as you move from left to right, you're gonna see an increase of atomic number, and as you keep moving down on the rows, you're gonna keep looking at the increase. Also, the rows, which are horizontal, are gonna be called periods in the periodic table, and the columns from up and down are gonna be called groups. Well, a period also tells us as you go down the period, so from left to right, you're gonna see also an increase in atomic mass. which is how much the atom weighs. And then down the column, you're gonna see similar properties. So for example, here all the atoms that will be on the same column are gonna have the same properties. For example, here we have alkaline metals, and all the atoms that fall in this group are gonna have similar properties, just like the alkali earth metals and the halogens and the noble gases. Here we have the transition metals, which have different properties from these two metals and other metals over here. They're all metals, they just have different properties. And then here we have the non-metals, like oxygen, carbon, sulfur. And then here we have the halogens and the noble gases. Here we have rare earth metals, which are some of the elements that were discovered last, and they have similar properties too. Here in blue. This is what a actual periodic table looks like, and they can differ depending on which one you find online or they give you at school, but they all have similar characteristics. For example, you can find it in color coded, like this one is, or you can just find it in black and white, but they all have pretty much the same information. Here we're gonna zoom in to one of the little squares and to see what the squares tells us. For example, here the number on the top tells us the atomic number, and the atomic number is the number of protons that we have. Below that, it's gonna be the symbol of the atom, and then we have below, usually it has the name, but it depends on which table you find. As you notice here, hydrogen and H, you can correlate them together, but it's not always the case. For example, iron, the symbol for iron is Fe, which you're like, oh, that has nothing to do with it. But that happens because when iron or some other atoms too were discovered, they were discovered in some other countries, and so when they picked the symbol for that atom, they picked it in whatever language that was. For example, some are in Greek, some are in Latin, and the recent ones have to do with whatever country they were discovered on, the name of the country, and that's why it differs a little bit. And then lastly, we have the atomic mass, which is how much the atom weighs. The atomic mass tells us how many protons and neutrons together we have. For example, here we only have one proton in the nucleus, so we have a mass of 1. The 0.00794 will be how much the electron it weighs, and that's not much. You can neglect it because it's such a small number compared to whatever the nucleus weighs. You can neglect it, and that's it.